Pleasant good afternoon again. Welcome to this session. Just for those who may be taking it on the um, Google Classroom anyway, right? And so I think I have been trying to send the videos like a past recording that we would have had. I normally send it, and I know I sent it to the WhatsApp group, right? But it's also it's a strange thing though, because when I say strange, those of us who know how Zoom operates, like when we finish today half two then, right? The recording is not available as yet. You just have to wait, right? And the strange thing with our Sunday course is that the very next day is Monday. So I'm off to work the following day. So what I have been doing is trying to find those recordings from our school YouTube channel. It covers the same content and put it up, but um we do have the Google Classroom. In fact, it is set up, all the videos are on it. However, I may not have admitted everybody to it, right? So maybe tonight I could dedicate tonight and maybe do some work in the nighttime from about 7 to 9. I could probably dedicate that time to see what's going on with the invites for the Google Classroom. Right? Normally if you take notes and whatever have you, but eventually you all like to look back at the recordings, especially coming up closer to exam, right? So I don't think there's a fear about not we have recorded them, but the thing is they are not. I think I did post to the WhatsApp group last week, right? And so another way I have been trying it is to put it on the YouTube channel and then copy that link to you all back on the WhatsApp group, right? So I think that's what I did last week, right? I would try the same thing this week, but the thing is it's not sorted out 2:30 then. In 2:30 the video is still processing. When you put it on Google, you have to run a copyright search on it. So it's never finished the same day. And the issue with that is that Monday comes and I try to sort it out today though, right? I try to sort it out today. If it's able to sort out today. Other than that, it is be a bit difficult when the week start to get back and to have the time to do that anyway. All right. So the last thing we did, trying to remember the last thing we had started looking at the safety management system. This is chapter 2 if you have your books, right? And we got back into the PDCA cycle, right? That was also part of chapter 1. And then we got into the MAP policy. That's where we left it last week, right? That in the UK, there's a law for major accidents. This is the prevention of them. It's called the Major Accident Prevention Hazard, the major accident prevention, well, no, in fact, sorry, it's called COMA, the Control of Major Accident Hazard Regulation. But COMA requires the companies that are seen to be like high-risk companies to come up with something called a MAP policy. A MAP policy is like a normal safety policy. But what it has in it, a commitment to prevent major accidents. You'll see it right here. And then there's also a commitment to protect the environment, right? So it's like a normal policy statement, but because these are high-risk companies, they would have to now commit now to preventing major accidents anyway. So we left it there, and if we could turn the page a bit, we will get back to page 29, 28, 29. And I'll try the explaining technique today, right? I really want to see how far we can go. And I'm going to read everything here today, right? And so we'll read one and explain, and then when we finish the concept, we move on, right? So let me just read this one. If you have your book, this is leading and lagging indicators. So measurement is a key step in process safety management and forms the basis of continuous improvement. There are two basic types of monitoring: active monitoring, which can be monitored by leading indicators and usually reflect taking initiative before things go wrong. Reactive monitoring can be monitored by lagging indicators and usually reflect looking at historical events to learn from mistakes and to prevent their recurrence. Let me take let's do one more again and I'll just explain, right? I think it's about the same thing. Okay, so for those of us who are in safety, we know that a company normally records what happens good for the month and what happened bad for that month, right? Those things are called the KPI sheet, key performance indicator sheet, and it's made up of leading and lagging indicators. Now, the leading is anything that is seen to be good, and the lagging is anything that is seen to be bad. So we have some here. There's also some in your book. You can probably look at page 29 a bit. So lead-in is anything that is positive, things like training, completion of a work on time, change out of any component that may have had to be changed and that was changed out, I guess, the way it was supposed to be. Um, Inspections, audits, all those things are seen to be leading indicators, right? Lagging indicators, I was saying last week when we were trying to close off, is that a lagging indicator for safety is not the same as a lagging indicator for um, normal safety, because like for a lagging indicator for everyday safety is like an accident. It's like, something happened, right? But remember we spoke about process safety. These are those accidents that are not every day then, right? So you cannot really say that an accident is a process safety lagging indicator, because by that time, you wouldn't be around then, right? The plant would have been in a catastrophe, fires, explosion, right? So what is understood to be is that a lagging indicator, so I need you to understand this one, is anything that doesn't line up then with how it should be for process safety, right? So you're not going to say accidents, incidents, because those things are catastrophes, right? So for a lagging indicator, the lagging indicators would be things like again, if I'll go back to the valve example, if like a series of valves had to be changed and they would not change, right? So then that's a lagging indicator. So you're not going to wait for the disaster, but you're using the things that didn't happen the way it's supposed to happen. So so even something like a sensor going off, right? So a sensor level gauge going off, and but nothing really happened, right? I mean, let's say nothing happened, but then that's a lagging indicator. Because if something happened, it wouldn't be a lagging indicator, it would be a catastrophe, right? So a sensor going off to indicate maybe a gas release or a liquid level had crossed the mark then where it's supposed to be, then those are the things that are going to be the lagging indicator. So what I did, I have a bunch of them here, and you could all read them out, because NEBOSH would give you four and you don't really have to take mine. But the opening of a rupture valve, the failure to open of a valve, things like those, right? A lot of these things then, right, is like operating like an equipment outside of the design parameters, right? So again, all of those things are lagging indicators in process safety, because you really can't wait for like a disaster then, right? So exclusion of process parameters beyond prescribed critical control points, or those for which emergency shutdown or intervention is indicated, right? So anything that sounds as if it doesn't line up, then that is a lagging indicator, right? So once you do those of us with the books, right? So look how much I have, right? I told you I have more than the book, but the idea is if it sounds like training, it sounds positive, but then it's a leading indicator. And if it sounds if you read something like this, like a compressor shutdown from a high level interlock on the suction knockout drum, I don't give anything like that really, right? And so if they say like the compressor failed to shut down, right? I think this is just one way, right? So if they were more clear, a compressor failed to shut down, then that is the lagging indicators, right? Uninterruptible power system malfunction. So something that's meant to provide power, but then that failed, right? So then that's a lagging indicator, right? Interlock test failure, um, fire gas and toxic gas detectors found to be defective during routine inspection and testing. So tell me if you understand, because I don't think they're going to use one from here. I just think that when they ask it and you read them, if it's positive, you would see there's one positive, because there's only one correct answer, right? And if it's negative, then if it's a lagging indicator, they will say something like, like what you're seeing here, something failed some sort of test, or it was outside of some sort of parameter. And then in that sense, it is a lagging indicator, right? So if you understand, because this concept is done, but it's something I wanted to watch in a book, and I want to reflect on a past paper question. Tell me if you're okay, you can put it in the chat. Okay. All right, so I wanted to watch those of us who have the books. Now if you don't have the books here, I'll have to write something on this slide for you, right? When you look at the book, those of us who have the books, right? What they did here, now, I'm trying not to waste too much time on this. What they did, right, in the book for lagging indicators. So this is such a, let me explain it first and I'll tell you why it is delayed on it a bit, right? When I'm explaining it, and you'll understand the predicament anyway. So for lagging indicators, right, in the textbook, what they said, lagging indicators normally start off with the words, or so start off the sentence with the number of, right? So if you look at the textbook, it will have the number of, right? So now this is what the theory suggests, and let me just finish it off and understand the predicament, right? So the textbook starts off all of the lagging indicator with the phrase, the number of. So the number of valves outside of test conditions. Any questions for me?
No problem. The hops was normal then.
Okay, I don't think that's for me. That's yeah. Yeah. All right. So the number of, right? So if it was a lagging indicator, it would have said the number of um valves that would not change out, something like that, right? So the number of, so this is what the book is doing. And then for leading indicators, those of us who have it, what is the starting of leading indicators? This would be, I think it should be on pages 29. Anybody? Just tell me. Just see if you can, now you're telling me to see.
Percentage of.
Yeah, so somebody, okay, good. So they start off this with percentage of. So if you want to get write that down, just write that down for me. Just replying to our students here, right? So the leading indicator starts off with percentage of, and that's what the book is saying, right? So let's see what happens now. That's percentage, the percentage sign, right? So percentage of training, percentage of, maintenance, percentage of, things that were good then, right? So that's all good. That's all good, right? And so I wanted to mention that. But I don't think that is the criteria for being lagging and leading then, right? I still think, so I wanted to understand what I said. The criteria for being a leading indicator is not percentage of, but the criteria is that a leading indicator is something that is good, right? And a lagging indicator is something that is seen to be negative. Then I just use the word bad here, right? So something that's outside of, the design parameters or whatever, right? So the reason for saying this is that, it's multiple choice, right? And they love to do tweaks, right? That's the best way to say. So I have seen a question, and I've seen more than one, where they ask you for, see if you're listening, right? I don't know if it's here, but they ask for like I think that asks for a leading indicator, right? And they switch the words, right? So for leading indicator, they had the number of audits. And the rest of words, but my 24 of them is four answers, right? So the rest of the answers for leading, they actually had they had percentage of. So they had percentage of for leading. However, when you read the whole thing, it wasn't positive. So like they had percentage of process parameters exceeded. Now, that's a trick. Folks, you understand the trick? The trick is if you was basing it on percentage of, you'd have gotten it wrong, because percentage of process parameters exceeded in itself, because you exceed, it is negative. So in that question, this thing in the book didn't line up. But what I said line up, because a leading indicator is anything that is good, and a lagging indicator is anything that is bad. And when you read the other three answers, they were all the same. They were all the other three, because they asked about leading, right? But the other three answers was like, percentage of deviations or percentage of valve failure. But the one that was positive, which was audits, right, had the number of audits completed. So you understand the thing what I tell you, the multiple choices out there to trick you. And that's why I kind of debated if to go through this with you. But it's a watch how it is in the book, where the book classified lagging as number of, and then leading as percentage of, but then the past paper flipped the whole script, and the past paper just went back to the idea of good and bad. So yeah, you can't ignore that. And the question was about orders, right? I think I told you the only one that was positive was on audits, right? So audits are positive. So if you say process deviation, valve failure, then the thing, the only one positive there is the one that had the number of, right? So tell me what you think. I don't know if you could take a note of that, because I stopped to write it, which is why I took a note of it, because it is a past paper question. Yeah. Tell me what you think. You okay with it? We can move on?
It's okay, sir.
Okay.
Yeah, we can move on.
Yeah.
Given that we're already on leading and lagging indicators, could we answer the question in the past paper that you would have given us quickly, just to make sure?
I could, we'd have to find it. You want us to kind of finish off some work, because
Sure.
and then we'll kind of try to incorporate it just after 2 o'clock, right? So keep your mind on that. We'll come back to that. I wonder if there's one in the book though. I told you maybe the book is the faster go at it, but the end of every chapter have some questions. And they are all past paper questions. It doesn't have one here. But I have one here, but it may not be, the exact question I just mentioned, but the past paper I spoke about, the past paper we gave that have questions on it, right? So that's try to finish up a bit more. Like I said, today have a lot of new things in it, right? And not every class is like that. You realize last week, like chapter 1 didn't have too much of new things. We spoke about, I mean, it had, but we spoke about the role of benchmarking. That is really not too new, or employee consultation. That isn't too new. Those are things we talk about for everyday safety as well, right? But chapter 2 have a bunch of stuff that is new in it, right? So see if we can find it on page 29. We can turn the page. And the other thing here is that really the only way to monitor then, well, those of us who know the purpose of the KPI sheet, that sheet is actually part of an audit then. The only way to sort of ensure that you're keeping up with your KPIs is to do an audit, right? So auditing of the PSM system for compliance, so a systematic independent evaluation of the current process safety management standards. So the standards can be your KPI sheet, right? For those, hopefully this is not too difficult for you all. And I tried not to draw a sheet because this is not part of the course. But for those who don't know what a KPI sheet is, it's like on a monthly basis. The company set a target, like what they want, right? So we can do something simple. So like if the number of inspections, we can say 30. You can say 30 inspections for every month. So you measure every month. This is February. Well, sorry, might have less in February, right? Or you could double up and still have the 30. But the only way to check that to see if you're meeting that target is to do an audit. So normally the KPI sheet is audited every 3 months, right? If you said, let's get a process safety example. If you said like the company had a shutdown, right? Like planned preventative maintenance then, right? And in the planned preventative maintenance, they wanted to change out X amount of valves. They wanted to clean out X amount of tanks and condensers and whatever have you, right? So that would be what they have for that quarter then. And the only way to see if you really do that is with an audit, right? So this is what they're saying here. Auditing the PSM system for compliance, right? So in the monthly basis, you record January 30 inspections, February 28, right? March 30. But the only way to sort of track that is to do like a quarterly audit, right? And I kind of give the exact figures, but in reality, you might not get 30 done. If the target was 30, you may have gotten 25 done, right? And so that's the purpose of the audit, to ensure compliance and aim for continual improvement, right? So that's the whole idea there. All right. So typical audit standards, and it's like whatever you committed to, that is what they will audit. So if it was the PSM system itself, the Plan, Do, Check Act, employee participation could be audited, process safety information, process hazard analysis. We're trying to come to some of those in a bit. Operating procedures, training. So have people been trained? I told you before, DSALCOT, I was there last week, Monday. I completed a NEBOSH accident investigation course for them. And they actually did a NEBOSH risk assessment. They all passed. Remember, I don't, saying all pass have none really to do with me, because remember, we have passed nobody. They went back to the UK, they all passed. They got their slips. This was last in November. So when I went this month, well, last Monday, which is Monday, gone here, right? They would have gotten their slips, but NEBOSH should have emailed them. I actually didn't have time to look at the NEBOSH is emailing results directly. Even this results, you will get it before me, right? NEBOSH have a way of giving you results on a Friday night. I'm not too sure why. I just said it like Friday, about 2 weeks after the exam, around Friday, 7 o'clock, 7:30, they send the results out to you all. But then the results take about 6 weeks to come. So that's what I'm with the DSALCOT. They passed risk assessment, they got the results slips, right? Their results will come this month. And then they did accident investigation. But I say that to tell you because they are doing process safety this month, the 19th, the week after Carnival, the Monday, Tuesday, Wednesday, they are doing process safety and the plan there. So, like I said, the process safety courses are standard. I mean, the DSALCOT is kind of water. They're not that too hazardous in a sense, right? But they are also doing, if that was the target, and if that's what they say, 10 operators, 5 operators, 6 operators, well, then that's what you measure against, because that's what they commit themselves to, right? So you can have a read of all the rest of them. We can get into 2.2 and page 33 if you have your books. If you don't have your books, just look on and we would take it from there. All right, so tell me when you're ready. And so I'll explain. This is going into something a bit deeper, but before we get to the deeper one, we have to cover the normal one, right? So which is normal safety. So I'll read this one. So risk management techniques used in process industries. The main objective of risk assessments is to determine the measures required by the organization to comply with relevant health and safety legislation, and thereby reduce the level of occupational injuries and ill health. Its purpose is to help the employer or self-employed persons to determine the measures required to comply with the Management of Health and Safety Work Regulation 1999, Regulations 3. I'll explain that in a bit, right? So to determine the measures required by the organization to comply with relevant health and safety legislation, to ensure the risk is acceptable. So I think they're talking about why do a risk assessment here. To fulfill a moral duty of care to employees, to prevent workplace accidents, to reduce direct and indirect costs associated with an accident, right? So what is a risk assessment? A risk assessment is a process used to evaluate the risk arising from a hazard or hazards, identifying preventative and protective measures, taking account of the adequacy of existing controls, and deciding whether or not the risk is acceptable. Risk assessment is an analytical process that identifies hazards, who might be harmed, and in what way they may be harmed. So in the UK, and let me read out this slide and then ask for that. So in the UK, the Health and Safety Executive in their publication, 5 Steps to Risk Assessment, INDG 163, state that risk assessments is a careful examination of what in your work could cause harm to people, so that you can weigh up whether you have taken enough precautions or should do more to prevent harm. And the same HSE, the same INDG document lists, you can find it on page 33, 5 steps of doing a risk assessment. First, they identify the hazard, then decide who might be harmed and how. Step 3, evaluate the risk and decide on what controls you have in place, sometimes called precautions. Record your findings, review your findings, right? So that's gonna review all of this. I'll just do the explanation. So what you're looking at here, folks, if you didn't know, this is how we do our risk assessment in Trinidad. It had nothing to do with the UK. This is how we do our risk assessment in Guyana too. This is how they do our risk assessment in any part of the world, right? Of course, I would have mentioned, you know, the standard and like the British system is like the standard, right? So around the world, Trinidad, Guyana, you know, these things didn't originate from Guyana, nor did it originate from Trinidad. It came from the UK. This is how we do our risk assessment, right? We identify the hazard. It's normally a column, though it's not like different columns. Decide who might be harmed, evaluate the risk, record your findings, review your findings, right? And this is what is referred to as normal everyday risk assessment. There's actually a formula for it. I'm trying to reach the formula, right? If not, I'll just write it on the slide for you. So there's a formula for it. Well, I could probably come down to here, right? So the way to calculate risk then, right, is that what they say is that you can calculate risk using words like high, medium, or low. And you can calculate risk using numbers, right? Or even numbers and words, right? So the most popular technique is in numbers and words, which are called semi-quantitative techniques, right? And what they do with that, they take two terms. There's a formula for it I was saying. So for everyday safety, they consider risk, right? And what they do, they consider the likelihood of harm occurring times the severity. Some people say consequences, right? So the most common popular formula is this, and what they use on either side, they use like numbers 1 to 5 here. Those who did the NEBOSH certificate already, you probably know this already, right? And they use numbers 1 to 5 here as well. And then they could estimate or ask you to estimate like how likely you think a hazard would occur. You choose a number from 1 to 5. How bad would the severity be? You choose a number from 1 to 5, you multiply it, and then you weigh that number over 25, right? You weigh the number over 25. 25 is the highest risk because the highest side here is 5. This is 5. And the highest this side would actually be is 5 as well. So 5 by 5 will give you 25, right? So the higher numbers you get, or the closer, if we were to draw it on a number line, the higher numbers you get to 25 is seen to be high risk. The middle numbers are seen to be medium risk. And of course, the lower numbers are said to be low risk. So this is the same idea that risk can be calculated using words, right? High, medium, low. But most companies incorporated numbers. When you incorporate numbers, it becomes a semi-quantitative method, right? So are you all familiar with this method? A bit of us familiar with this method? Okay, let's get the answer first and then I'll check out Jillian. Are you all familiar with this method? Because the truth is, this is the one that will not come because this is the step up. Remember, you all are doing a level 4 course, right? And like we have mentioned that, like when I teach it, I will teach back the level 3. So this is the level 3 knowledge base in here. But process safety is beyond this then, right? So, but to reach where we have to go, we have to come back to talk about how to calculate risk. Right. So I was asking, so are you all familiar with the risk formula, likely by severity, the 1 to 5 matrix? You can let me know first and then I'll get back to Jillian.
Yes.
Yes, okay. But if you wasn't familiar, I would actually pause and do one. I would do a calculation. We could probably use a tank or a vessel or something. I think I'll still do one, right? Just as because I have this thing right, I have it written up already. I might as well just use it. Right, so I'll give you one and we could sort of estimate it. But I'll say again, so if you write in notes, you know, like sometimes we see something and I say, look, this is a question. I would say again, this is not a question. You don't ask it to calculate risk. They don't, right? So we have process safety risk assessments, but you wouldn't get this one. You'll get the ones which pertain to process safety. If you turn the page in your book after you look at page 35, you'll see the same thing on top. qualitative, quantitative, and semi-quantitative. But if you turn the pages and you see some new techniques, so what they will test is the process safety RAs. They won't come back to the level 3 RA. So even if I do one, don't feel this one coming, right? I've never seen a question on like a normal RA for level 4 anyway. Yes, Julian?
Yes, sir. I just had a question, in terms of risk assessment.
Yeah.
This is equal to the likelihood multiplied by the severity, right?
Yeah.
But I was wondering, sometimes it's just of your opinion. You have to guess if you think that the risk is 1, the likelihood is 1 or 2, or is there, like from my whole time within safety, and I know that the rating will be 25, but is there something that you could specifically say it will fall within 1 or 2? It's always based on your opinion.
Well, there are 2 answers to that, right? So I'll come back to Alanson in a bit. Let me try to answer that. So, or maybe 3 answers to that. So the first thing I said, nothing is wrong with when you say it is your opinion, right? So even the best safeties then, right? I mean, the formula they have in the world today is this formula. So a regular safety is going to use this formula. Now, there are ways to make the formula more accurate, right? But if you're using the matrix 1 to 5, you can't really make this formula more accurate. So there's always going to be an element of subjectivity in it. And nothing is wrong with that, right? Nothing is wrong with that. So the only way I could think about to make it less subjective is you have to involve more people in it. So if you say 1, okay, like the likelihood is 1. 1 is low, right? 1 means that nothing really going to happen. But then somebody else may say 2. So the only way to get away from this subjectivity for using this formula is to get more people involved in it. And the more people that take part, then the less subjective it is. But it is subjective. And at the same time, nothing is wrong with it because there is no set number. I don't know if you understand that. Like, somebody did a calculation and got 20, and then somebody did it and got 25. The point is it still is high risk. So in a way, the number itself is not what is important, but is the range where the number fall, right? So if something is 20, 25, the outcome is still the same. Stop the job, put controls in place. If somebody did a calculation 2 by 2, 4, and somebody did another one 3 by 2, 6, now the range still ends up being low, right? So in academics, if we come back to that, in academics, there is no answer that NEBOSH is looking for. Then they're not looking for 25. And in reality, too, in the real world, we're not really too concerned that it is 25 or 20. The point is it falls in the same range, so we're gonna have to stop the job anyway and put control measures in place, right? 2 hands went up. I'll go back to Alison first. Yeah, I'll go to Alison first, and then I'll come back to.
Well, I guess you answered the question because what you're saying was objective now. Because there's how contractors come in by us and they have to like submit the risk assessment and JHAs.
Yeah.
And like when I go through it, some of the things what they're saying is like low, I find is like seriously. So
but that's different though, because that shouldn't be.
Yeah.
In that sense, you have to correct them, yeah.
Well, yeah, I do.
Yeah.
Eventually I do and like tell them what to do and stuff, something like that. But I think you explain everything.
Yeah. Right. Get back to Jillian.
Yes, sir. It was explained properly to me too.
Okay.
And,
for those, I mean,
I just wanted a little clarity on that. That was always one of my things that I just wanted a little clarity on.
Yeah. Okay. I thinking to say something, but that's not this course. I remember telling all the right folks that might have more knowledge out there, right? So like there is a way to make the formula more accurate, but you have to incorporate another term in it. You have to put L by S by something else. Likelihood by severity by another term, right? And you make the formula more accurate. That's a whole discussion by itself. So I don't want to get into it because when I say the discussion, it's like an example. You have to give an example for them. I have to tell you what to multiply by. But you can understand like the more numbers you put then, 5 or 2 by 3 by 2, then the more numbers you put, then you have a chance of being a little bit more objective, right? But in reality, what I'm saying is that this formula itself is subjective. There's no way to make a subjective formula objective, right? You think you agree with that? And so,
So
what I can
excuse,
tell-
but
yeah.
you said that you would have done an example for us as well.
Yeah,
That-
I think it's still, I think it's still.
Oh, okay.
No, I try to incorporate, I try to tell you that, I try to see how to go down this road now. Like, now, so there are other techniques, right? There are other techniques beside in this formula. Like, and it's in your book, but not all in your book, because remember, there is level 6 as well. So if you want, turn your page on, as we on this, I want to show you something before I take this off, and I'll give the example still, right? So when you turn your page, you're gonna see, now, there's a reason for going on this road, because what I'm gonna tell you here wouldn't be wasted, because it's an exam question too. So best we just do it one time, right? In the thought of objective and subjective and objective and subjective, that is a passive question, right? If you're going to say it again, I'll say it again. What you're looking at here, L by S not coming for you. But a famous question is like, which of the techniques is objective and which of the techniques is subjective? Which one is better than the other one then, right? So if you turn your page, if you're on page, and I'll turn it here too when I reach it, right? I'll write it on the slide for you now, page 36, right? 37, 38, you'll see a whole bunch of other techniques. Remember, this is an advanced course, right? This is not level 3, this is level 4. This is what we tell students from the beginning. But, you know, like a level 3 student would stop right there. That's all you need to know, L by S, right? But this is level 4. The only thing with level 4, which is good, is that the exam is easier, which is also good, right? It's not a bad thing, but the work is way deeper, right? So when you turn your page 38, you're gonna see Hazops. So you see more techniques. Now, all of these, if you look at the heading, the heading is that all of these are risk management techniques, right? Watch it in the book. I haven't had a chance to turn this slide yet, right? But all of these are advanced RE techniques. A Hazop is an advanced RE. A hazard, page 59, is an advanced RE. An FMEA is a very advanced RE. And let's get to the one that they like for exam, the ETA. I had mentioned this to you last week. I just need a little bit of space here to write it. I want to write it because, folks, of all that we see, and this is the best one, right? The ETA is the best one. Now, you don't see it as the best one in your textbook because they didn't show you the calculation in this textbook. But the ETA and inventory analysis, so if you want, this is also on my notes now. Just that you all mentioned it, so I'll say it one time. When I reach it, I don't have to explain it again. So an ETA is an objective way of doing a risk assessment. I'll tell you why. In fact, if you want, we could go down there, but so ETA stands for inventory analysis, and it's objective. Now, you might ask, why is it objective? How is it objective? Well, it is objective because, let me explain, huh? Marathon is what you have here first. By the way, I mean, like I said, typical passive question, they say, which of the techniques is the best one? And they'll give you 4. The answer is always going to be ETA. You can, I don't know if you remember that, when we go to the passive just now, you'll be able to do the question. Even if we mightn't reach ETA today, the answer is still going to be ETA, right? And inventory analysis. Now, the reason is, if you read it up in your book, but we mightn't reach it today, right? Is that an ETA uses what is called binary logic. I'll explain, right? So if you have seen the movie Matrix, which we all have, if you have seen the movie Matrix, right? At least the start of it, we all have seen Matrix, right? What shows on the screen at the start of the matrix, or what ends up the screen at the end of the matrix? Like, what is binary logic? What is binary? Binary is what?
The binary code, like 1 0 0.
Very good. Okay,
Yeah.
so watch my hair a bit, right? So this calculation assumes very specific numbers. Like there are numbers between, you know, this one using 1 2 3 4 5, right? This one using like the likelihood is 1 2 3 4 5, right? So, you know, the normal risk assessment using 1 2 3 4 5, but it's ignoring the fact that there's a whole bunch of numbers between 1 and 2, right? There's 1.1, there's 1.11, there's 1.12. So this one is very accurate. This one is used by the military. If you read up on it a bit, like precision weapons, bombs, right? Drone attacks, right? This is where this theory came from. Not theory, sorry. This is where this calculation came from. This is how they know. This is the programming part of it, right? So there's a whole set of series of numbers between 0 and 1, and an ETA calculation uses that. So an ETA calculation may have something like 0.98. So you see the accuracy. And of course, if you think about the military and drone attacks, and you've heard about these things, right, in the world today, precision, well, so they claim, right? So 0.98 by 0.5777. So this technique is always going to be. The other thing with this technique is that it doesn't have any words. What have a meaning is the number at the end, but 0.98 doesn't mean high risk or low risk. So this technique is seen to be what is said to be a quantitative technique. It's on the other slide. If you want to watch it, remember there were 3 techniques, right? Qualitative, semi-quantitative, and quantitative. Quantitative, and you can think of it as pure maths, right? And the numbers will never get above 1. If you want it, 0.98 is less than 1. It's precise. It uses binary logic, zeros and ones, or the numbers between zeros and ones. You don't have to remember nothing like that for exam. You just have to remember that saying the best technique is always going to be ETAs. If you remember that, you pass the exam question, right? They will give you all these other techniques in the book. Hazops, they may even give you back that, well, they already give you back that formula, but they may give you back the other techniques, right? But the best technique, the most objective technique, and even data studies are question, which of the techniques are objective, and they give you 4. They give you 4 answers, right? Hazops, bow tie analysis, ETAs is inside there, hazards is there. The answer is always going to be ETE, right? Now, an ETA, well, I mean, I'm saying too much here, right? But
so you could just repeat what you just said before. I didn't catch that.
I wasn't paying attention myself, right? Somebody will have to say. I think I was saying something like an ETA is always going to be the best answer, even if they give you 3 other answers then, and they say which of the following is the most accurate, or which of the following risk techniques is most suitable for high risk operations. A question like that. The answer is always good. And of course you must see it, because if one technique is using numbers like 1, 2, 3, 4, 5 and ignoring the fact that there are more numbers there, the ETA is not doing that. The ETA is taking account of 0.5777, right? And the next number is 0.5778, right? So if the ETA is doing that, the ETA is always going to be more objective. And I was saying that these numbers don't really have a meaning. It's just a calculation, right? And then at the end, you get a number, and then but that number to the end have a meaning. So it's more objective than it is subjective. And with that knowledge, you could pass any of these ETA questions, even if they didn't show you how to do one, right? I will show you how to do one next week, a bit. We can't get too much into it because there's a lot of formulas into it. The most you can probably see is the first stages of an ETA, where you now start to minus, and you now start to do the calculation. But there are no calculation exam questions for NEBOSH then. Well, not in level 4, they have it in level 6. I don't know if I answered the question because I was just talking. I don't know if I answered what you all asked anyway, right? You could let me know if I did. I wasn't really consciously thinking about what I was saying. I was just talking about an ETA. To the bottom of page 40 though, they show you a very basic version of an ETA. I don't even know how to describe that. That's not really an ETA, but what you get from it, right? You get from it an ETA is like I tend to call it like a sideways family tree, right? So an ETA, I'll do one for like this way next week. But again, these things are kind of beyond the course. It's not as if you're going to get to do an ETA. They're just going to ask you which is the best technique, right? So an ETA is like a sideways family tree. It's like a family tree, but it's on the side. It's like that, right? And every line you see I put in here, it actually have a formula for every line. There's a very detailed, risk calculation. It's the most detailed one they have, in fact, Again, which is why they say it's used by the military for like weapon precision, right? And even this is actually used by manufacturers, believe it or not. You ever wonder how come a manufacturer would know, like the battery in your car have a 3-year warranty or a 1-year warranty, and the minute that month comes and goes, the battery stops working. How does the manufacturer know that? How did they know that? Do they pre-test a battery every time before? No, they use a ETA calculation. You can get a precise number of years. If they know it's like 1 year or 1.5 years, they may give you a 1-year warranty on it, right? Precision, just think about that, weapon precision, right? And that's how precise it is. At least so they say, they will, take out who they want to take out, right? All right, folks, I can go back to the normal one now. I just need a little bit of space so I could take off this here. I'm taking up the one in the ETA, right? And we can just go back and do a normal calculation. But like I said, the normal one is the one not coming. And this one I'm doing here now, this is just practicing using the risk formula, right? So if I'm just gonna drop a manifold system here first so that you have a vision, like a vision thing to follow, right? So some sort of silo, right? Connecting to another tank, right? And let's say this is the tank here that we have to clean, or this is the chamber that we have to clean. I think this pipe went the wrong way, but anyway, you get the idea, right? We could put it here, put a valve there or something, right? So yeah, this actually may lead into another pit or whatever have you, right? So let's say this is the vessel that has to be cleaned, and we're just gonna I'm gonna do this one quick because remember this is not your exam, right? We're gonna say that this was isolated. They did do some gas testing on this particular vessel for hydrogen sulfide. We would also assume the way to clean this is the workers have to go inside of it. So there's probably like a tank door that they have to get into there. That tank door would have been open. There probably is like another opening to the top here that has been open, right? But we would suggest now that there is actually no rescue. There's actually no secondary rescue available, right? So we have to give the conditions of what is happening here. There's no suitable rescue other than the company itself, and there is no first aider. There is no, let's put FA there. There's no first aider, right? There is no ambulance standing by, right? So let's think about this one a bit, and we would want to say yes, that this tank had some sort of residue in it, which is why I put the hydrogen sulfide, right? So based on what I said, this is a subjective nature, but we want to ask then like, well, first of all, we have to get what is the hazard, right? We have to say what is the hazard. So what's the hazard you think would happen there? So we have isolated, we have tested for the gas, but there's no rescue. And we don't have a first aider and stuff, right? But so what do you think is the hazard? Anyone? What do you think is the hazard? Okay, this is an easy one. Okay, so the hazard would mostly be like work in a confined space. And there are a lot of hazards associated with that, like difficulty in breathing and being overcome with the gases and whatever have you, right? So I just put confined space here as a overarching term. And you can tell me, I guess, on a scale of 1 to 5, how likely you think, so I guess we could reflect it back to the breathing, right? But which is critical, right? I mean, so that's why this, right? So breathe. I think I got it wrong. Okay, so what was it likely to think of somebody having difficulty in breathing inside of this vessel? On a scale of 1 to 5. 1 meaning no difficulty, 2, minor difficulty, 3, moderate, 4, major, 5, death. Anyone? You should probably put in numbers in the chat quickly, because this is one that's not coming for you all. So I don't want to waste time with this one. Just pick a number. So do you think it's likely that somebody could have some breathing problems inside here? Is it going to be 1 then, or is it more likely to be like, we said kind of likely, probably maybe about 3. We have isolated and we did do a gas test, right? Okay, so you see what's happening is like why we need to have people. So this is demonstrating to you all the subjective nature of this formula, right? So I seen 4, I seen 3. If it was a real company, I would have probably asked you to say, okay, I see more 4s, right? So because I see more 4s, that's how they do a risk assessment too. The more people that agree on something, you kind of go with the worst possible outcome then, right? So we did isolate, we did test, but we don't have any rescue. I think I want to go down to 3 though, because remember, I did isolate the tank. The hazard here is breathing difficulties, right? So if we test, the gases must be within some sort of limit. Otherwise, somebody would not have gotten inside there. So I want to go with 3, right? I think 3 is that it may have some residue still, but they would have tested. The fact that they would have tested meant for those of us who know that it would have been safe then. Otherwise, no one should have already gone in the tank, right? So the test for H2S, so let's say the limits were safe. I'll go with a likelihood of 3. The severity, if they were to be overcome, what do you think would that be now? I don't have a rescue team around, and I don't have a first aider or anybody competent to deal with that, right? But we did open the vessel. Those of us who, this is a normal thing, you open the tank and you isolate the supply or whatever. So that's like good enough for a lot of companies. So that's why it's 3. A lot of companies see that as being good enough. And a lot of companies don't take the trouble to go and get, a first aider or the ambulance services to come by. Some companies do in Trinidad and actually in Guyana too. I think you all know a lot of companies on the plant here. And of course Guyana too, because I know that a lot of Trinidadians are going across. They have a lot of them. I have folks who go across there as medics, right? The companies are somewhat from here, sometimes they're from Guyana, but they hire around the board anyway. And a lot of persons they take on, for those sort of work to act as medics and emergency rescue. Those of us who know about shutdown in Trinidad, that's a must. Atlantic LNG have their own, so much of companies have their own ambulance services and stuff, right? But what we have assumed here, so forgetting Trinidad and Guyana, forgetting that, what I assume here is that I don't have a rescue team and I don't have anybody like that here. So what do you think could be the severity if somebody did get into some difficulties? Put back an answer for that one quickly. You think it'll be low numbers or high numbers? Let's hear from, okay, Cindy have 4 to 5 severity. Anyone else want to kind of chime in? I'll just take one more. Okay, 4 answers there. Sorry about that. I was let me just try to get rid of that. Okay, so I'll go. I think if it go worst possible, I'll come in hard to go with 5 because this is breathing, right? So everybody, I don't know if you know like everybody is different. They call that an atopic condition. So somebody could have gone inside it. Yes, the H2S may be within limit, but what if they did get into breathing difficulties? The point is, we don't have anything to help them. Closest hospital may be an hour away, right? So I think we'd have to go with 5, right? And this would be, when you get this final calculation, this would be 15. 3 by 5 is 15, but it's 15 out of 25, right? So, controls are needed, and this is sort of high, right? Further controls are needed, and the controls would be the ways to address what we left out from this then, right? So that's how we do a normal risk assessment. And again, like I said, this is the one that possibly wouldn't come for you, right? Folks, I want to do one advanced technique. It's 2 o'clock, right? I want to do one advanced technique before, well, we do anything else, right? So let's do, I'm kind of choosing one. Well, when I say kinda, I mean, I'm choosing one, but I'm also choosing one that's popular, right? So if you turn the pages, like I said, you turn the pages in your book of the advanced RAs then, right? ETA is your best one for exam, right? Well, if they ask which is the best technique, but they have other questions on some of the other ones. And one of the popular ones is something called a Hazop. A Hazop, right? Page 38. Hazops are more popular than FME. Hazops are more popular than hazards. Hazops is popular, right? So let's do that one if that is the most popular one. Not the most accurate one. That's another question, right? The most popular one for a question then would be like a Hazop question anyway. Or if I have to choose one, I would choose Hazop for now and then work the others in probably slowly next week, right? All right, so let's get to that. So the same thing I mentioned that we spoke about is here. There are a series of different types of techniques. Qualitative techniques are like hazards, Hazops, bow tie, FMEA, failure mode effect analysis, what if analysis. They are all qualitative. Now, why are they qualitative? Because the one we're going to do is a Hazop. But if you watch your book, page 38, what you're seeing on page 38, even on page 39, is only words. So therefore, if it uses words, a Hazop is an advanced RA, but it's not good as an ETA. But again, there are individual questions on some of these. Bow tie is kind of common as well. Okay, like on this slide, the two common here is Hazops and bow tie. You really don't get any FMEA question, right? And the quantitative techniques, we mentioned this one is that they include techniques like the FTA fault tree analysis. This one is not in your book, but I have mentioned to you all many times that the slides have a little bit more than the textbook. So fault tree analysis, right? Hazards, hazard analysis. This is not in your book either. But this one is, which is the ETA, the event tree analysis. And these are the ones that are more objective because they rely on data then, right? And it's very precise, very reliable. I think we explained why those things are like that anyway, right? So this is back to the formula here. You can read that up. This one said likelihood by consequences. We had likelihood by severity. And let's go to the Hazop, right? So all of these are advanced techniques. Let's take a look at that in your book. The heading for them are all risk management techniques. And let's have a look at the Hazop, right? I'll just read one slide for you and I'll try to explain it for you. I feel I'll open my whiteboard and I'll explain for you, right? I'll read probably two things until you can't understand the rest, until you have to explain it, right? So a Hazop, first used by ICI in the 1960s, a hazard and operability study. And by the way, that's some military company, right? Is a structured and systematic examination of a planned or existing process or operation in order to identify and evaluate problems that may represent risk to personnel or equipment or prevent efficient operation. Hazop, right? It would identify deviation from a design intent. I'll have to explain that. Determine the causes and recommend solutions. It is a qualitative process, which is why it's not the best technique, but it's also a technique, right? So a team of experts on various disciplines are involved. However, a team leader is normally required. I'll talk about that too just now. It is best used at the design stage in the process, but can be used for plan modification. Team members could be anybody, but they have to be competent, right? A scribe is very important if you're developing a Hazop, right? Design engineers, mechanical engineers, everyone that is kind of competent about what they do in the Hazop for, right? Process engineers, safety specialists are all part of the team, right? So let me explain. I'm trying to see if I read a bit more. I think I'll read this one slide, right? So Hazop, the procedure, the scope must be defined, such as the part of the process, plant operation that will be studied. The parameters or a parameter must be chosen. Typical parameters can be flow, pressure, temperature, level, viscosity, composition. Whatever you want to study, that's called the parameter. That's the simplest way to say it, right? Temperature of sulfuric acid in a pipe more than 20 degrees Celsius. Guide words must be chosen. The guide words could include a lot of words. They have some in your book too on page 38. Guide words could be no, more, less, as well as part of, reverse, other than. There's a whole list of them. You can just Google guide words, Hazop guide words, and come up with way more than these, right? So let's start to explain it a bit, right? But for that, I don't know if you would want to write anything, or you can just look at your book. You just look at your book, to be honest, right? And I would open my whiteboard here and try to break it down for you a bit, right? So with the Hazops, right? Like any other risk assessment, there is a format, right? And so let's write what the format is. So the format is what you see in your book. The format is normally represented by the letters G, D, P, C, E, right? And if you look at your book, you can see what these stands for, right? Just gonna take it back to the top. I'm going back to the way to the top, right? What is a Hazop? A Hazop is an advanced RE, right? A Hazop is an advanced, it's another way of doing an RE. It's an advanced RE. Stands for though hazard and operability studies. It's an advanced RE, right? And like an RE, then there is going to be a table. There's going to be, you know, a way to do it then, right? So these words here make up the columns of the table, right? So you have guide words. If you look at your book, they put parameters there first, but parameters are normally to the top. The parameters normally stay to the top, like to the top of the table, right? So the guide words, I just put guide there. They have deviations. I just put DEV. This is in your book, deviations. If you don't have your book, you can just write on this one. So this is really guide words. This is deviation. The P is possible cause. If you look at the book says cause, but it's actually possible cause or causes, right? Possible cause or causes. The C, if you have the book to the C says consequences of the deviation. Consequences of the deviation. And the A is action for improvement. Right? So it is an RE. I wouldn't draw the colors between these two, but if you have the book, you'll know that this is, I'll try to show you the book over the screen for those who don't have the book, right? So the A is action for improvement. So it is a table, like a normal RE, right? And so guide words, deviation, causes, right? But like I guess at the other levels and at the higher level, parameter really is not part of that. The parameter is what you're going to study, right? So if we go back, let me try to use, I'm going to use something from home. I guess we could use your phone, but I'll use the iron, right? Like, you know, like the electric heater. Or electric heater, it could actually be a water heater as well, right? So we could do that, and I could just do like the piping system, like I mean, no offense here, but the piping system to like a shower system, right? So like if you have like the central water heaters, so so wherever the heater is then, right? So this is the shower head here, right? So wherever the heater is, if you have, you know, like a portable heater on this, fine, right? And if you don't, and you have, this is a piping system here to a central heating system outside your property, right? This is the piping network here, right? We can still use the same thing. It doesn't matter. Both is heat we're talking about, temperature we're talking about. So the flow then, right? You know, we can look at flow for another one, but speaking of temperature, we can look at temperature. So the parameter here would be temperature. So whatever you decide to study, if you are studying the flow of water, right? In the process, in this case, a simple kind of shower system, right? So the parameter is, for now, we're going to say temperature, right? So if we're getting hot and cold, so that's what we're looking at, hot and cold, right? So these are the constants, right? The constants is the table is always going to be that guide words, deviation, possible causes, consequences, action. The parameter is going to be temperature. Folks, let me give you a minute to copy down. And because I need is going to fill up in a bit as well, right? Tell me when you finish if anybody writes in. If you're not writing, also tell me so I know not to wait.
I'm finished.
Yes, sir, finished.
All right, okay. All right, so make sure you have this one, right? So just remember parameter, whatever you want to study, if it is like I could think of 100 different things. If you're thinking about the radiator in your car, it's the same thing. You can do a hazard for a vehicle like that, a vehicle. You can do a, I mean, this is process. I mean, this could be like a chemical, you know, process too, where we're looking at temperature, but we're just using something at home, right? But whatever you're studying, that's called the parameter. That's what the slide before listed a lot of parameters. Back in your book here too, right? For the parameters, I read it from the book, flow, right? Whatever you want to study, temperature, they list a set out in your book too, but whatever you're going to study, that's called the parameter. I was trying to see one that I did. Probably not relevant to you all, but like, you know, like again, like I have done this for, we have done this for desalcot, right? And I could actually do this of making a cake. You can look at the oven. You can look at a microwave, like, is it getting the heat? Is it not getting the heat, right? But whatever you decide to study, you know, that is said to be the parameter. Okay, so the next thing here, we were saying a team of specialists does this, right? And what the team leader have to do, I'll just draw a stick figure here. What the team leader have to do, in a Hazop, what they use codes. Yes, they use codes. Code, C-O-D-E, so they use codes. And the codes is the words that you were saying before. The code, so the team have to agree on the code. So this is the other thing, right? They can't just use a code and the people don't know what the code means. The team have to agree on the code. So the codes go like the word more. The codes go like the word less. And what those words mean, I mean, it means what you think it means. Like more would mean that the temperature is getting hotter than it should be, right? Less would mean the temperature is not getting what it should be, right? So let's say this was the shower system itself. I don't think anybody would, again, some people are different. Some people may bathe with very scalding hot water, but I would want to suggest something around, anybody can help me with this, I'm not quite sure. I really don't, I have one of this one, but I prefer cold water all the time, right? So I would want to say something around 28 degrees Celsius, maybe 30, because if it's to get beyond that, right? That's like now spa conditions, like a spa, if the water is that hot, 34, 33 degrees Celsius, right? So let's assume, okay, let's say it was 30. Just to make life simple, right? Let's just say it's 30, because we're in the Caribbean, and we may be sort of accustomed to, you know, high temperatures. When I was in the UK, if anybody have traveled, I had a difficult time convincing somebody that the temperature was 30 degrees Celsius in the Caribbean. They couldn't understand what I was saying, right? They could not understand what I was saying. I know you all may think that kind of weird, but they couldn't understand the temperature would be 33 degrees Celsius as a normal day, 34 degrees Celsius. They couldn't, because for them, the temperatures never get so high. And that's normal for us, right? So let's assume that the water in the shower is warm water. I'm not going to put it too scalding hot, right? But what more would be, more will mean that like when the team, like this row of the RA, the team is considering what would happen if the temperature gets hotter than 30. You understand? So the deviation will be, watch it, that's what your book says. If you watch it, temperature, for the deviation, what do they have? If you have the book, they say more temperature. So there's a temperature increase. If they say more, the temperature is increasing, right? If they say more, the temperature is going to go up then. So the team is considering, remember this is an RA, don't get too lost. This is predictive. This hasn't happened yet. Remember, an RA is predictive. When you say, what is the likelihood of somebody falling? And you put 4, the person didn't really fall. But you're just saying, what if they fall, right? So this is another form of an RA, a more detailed version of an RA, but this hasn't really happened. The team is considering, what if the temperature increases? What if more happens? More means when the team says more, all of them will think about the temperature increasing. Right, folks? I think you understand it. And likewise, if they say less, when the team say, let's consider now less, then they will consider, well, what if the temperature decreases in that the water coming out of the shower is not hot, right? So the next thing to do, what's the possible cause? Now we could just do two here because it's just an example. So what's the possible cause of the temperature increasing? Anybody can guess it? I could give you one. So a possible cause could be like a malfunction of the heating sensor, right? So the team is going to consider what is the possible causes of the condition that you are looking at. If you said more, well, temperature increase, right? So then that could be, a possible cause. Could you give another possible cause? What do you think would increase the temperature? You're in the shower, but the thing is getting too hot. You set it on 30, but we're thinking of, and this is really not really reality, but I'm saying this is predicted because what if the temperature increases? What is the possible cause of that? Anybody? Quickly. What is
A malfunction in the machine.
Okay, so another defect. Okay, I'll leave it there. I'll leave it as malfunction there.
Sir, human error.
Okay, good. So that's now, again, I'll put that one. So it might not be in this example, but of course, with another process, human error could be an example, right? Human error could be an example of why a valve wasn't closed off on time or something like that, right? Human error could be an example. Okay, very good. Anne, I was looking for that. Anne Barron, right? Said it. I was looking for like a voltage problem. Like, yeah, like a voltage issue. Yeah. There's supposed to be voltage, right? So we talk about that. Okay, so again, and those same, okay, so no electricity would work for this one here. So that's a very good one for decrease in temperature, right? I write it, folks, right? I think it's Beverly. That said it, right? So Beverly said no electricity. Definitely that would be for, for the less, right? But like when the water now is actually cold, but you wanted to take a warm shower, but there's no electricity, right? So again, and these would work to malfunction error, right? So what is the consequence? So the consequence here is that if you look at the book, you have hot water or hotter water, if that's, I guess, even possible, right? So you'll have the consequences. The consequence is hot water, and then this could lead to some injuries then, right? So it could lead to like scalding injuries, right? Burns, right? And then even probably worse, you may not have been able to take a shower at all because the water is too hot, right? So no shower, right? So you see how this is simple, right? I could do this for making a cake. I mean, this is kind of like a household example. We're using an advanced technique on a household example here, but this could be for any process. You just have to hire me and I'll come to your company and get it done, right? All right, the last thing in the action here is action plan for improvement. Like, how do you prevent that? Remember, because an RA, if we go back to an RA, like what is the purpose of an RA? A purpose of an RA is not just to say the risk, but it's to prevent it. An RA, if you know the normal RA, like they once you calculate the risk, you sort of put controls in place. So that's what this is doing. This is action for improvement. So I'll give you one or two. So how do we prevent the malfunction of the heating element? So we could probably have regular inspections, right? We could probably adhere to any sort of change or requirement from a manufacturer, right? So again, this could work in other companies too, things like, like change the components if they have, reached their life. You could use that one for the companies because I know we're not doing that at home. The one at home, you're going to run it out until it stops working, right? But this is what the process feed is all about. That's why they have shutdowns. That's how they know based on the manufacturer spec that this valve have to change. This catalyst ain't good anymore, right? Because there's a time frame for it. So we need to change it. Otherwise, it's going to affect your whole process, right? how could we prevent the voltage issue? So the action for improvement have to do with the possible causes. If you notice, they're trying to address these. The malfunction can be addressed by an inspection. The error could also be, solved by the inspection. The voltage issue, how could you address that? How could you address voltage issues at home or in a company? There's some common devices that you could use.
Sir, in Guyana, we would have a regulator.
Right, a regulator, a
So-
surge protector, right? Very good, right? So folks, this is actually what a Hazop is, using a household example, of course. And what you just did here, I have done this in Guyana. We did an oil and gas training course across there with them. I don't think anybody here is in that batch or was in that batch. I am back there again the last week in February. If anybody in Guyana, you want to get into that oil and gas 1-week program, contact the New Guyana School. You can probably message me tomorrow, right? And it's just 4 days, Monday to Thursday. And these, as well as some other oil and gas stuff, they are taught. But the point of all of this story now is that you won't see this again. Unless if you're doing it in your company, unless you want me to come in to get it done in a company. But you're not really seeing this for your exam. I just went through one with you, so you'll understand, right? So if you want, let's reflect on a past paper. I'll just tell you quickly, right? So some of the past paper questions I've just asked very outright. Like what is a qualitative technique? Again, if Hazop is there, you want to give them Hazop as the answer, right? I'm gonna shout a couple now, right? I don't know if you're writing anything. I'll shout about 3. I could just remember some, right? I mean, some common questions here, right? Like one of the technique was which of the techniques uses guide words? Well, ETA don't use guide words, but Hazop uses guide words, right? Which of the technique has a deviation from the design intent? That's also Hazop, right? So what I'm trying to impress to you now, in the 4 minutes I have, is that you may need to learn this up here. Well, not me, I think you should. Because remember, this is not an open book exam. You're going to have to learn these words, the heading for the table. But if you remember the acronym, I guess that should help you a bit, right? GDPCA, it doesn't change. If you do a degree in safety, it doesn't change. You do a master's, it doesn't change. Like the 5 steps in a risk assessment doesn't change. It doesn't matter what you're doing. The five steps in normal RE doesn't change, and this wouldn't change either, right? Let's have a look at the. In fact, no. First of all, let me know. Do you have any questions? Do you have any questions? So what we did here, we looked at a Hazop for sort of taking a shower, right? Like what could happen if the water is too hot, more temperature increases. If the temperature, doesn't get hot at all, so then you don't get a hot shower, temperature decreases, right? Some of the consequences, hot water, scalds, burn, the fact that we're not able to take a shower at all, right? And the last part of it, action for improvement, inspection, change components, regulators, right? So see if you have any issues with that first of all, and then I could probably take 5 minutes of your time to look at the past paper. Any questions on this in terms of if you understood the idea of a Hazop?
Yes, sir.
Okay, so have you understood the idea of the code? The code is not really that difficult. The code, I mean, all of these things is from the military. So when the leader tell them, okay, more, like when I say more, everybody would think is, like something increasing then. And if the parameter is temperature, well, when they say more, it will be temperature increase. This could be used for anything, filling bags with cereals, cornflakes, products, how much to fill a container with. They use this for these things, What if you have so much more in your container? What if you have less? Somebody bought, a bag of sugar, but it's less. What if, because it's that kind of thing, what if there is less product in your products, right? Hazards could be used for anything, right? So the guide words, no, we only did 2, which is more and less because that's what the book have. But if you look back at my slide, it have more guide words. Like if you find something in the sugar, right? Then there's a, well, what if a contaminant gets in your product, right? So I have to be careful how I say in this one here because I know I have some people here. But last year a company called me for consultancy. I just make this story short, right? They were bagging products for Price Mart, right? So Price Mart, I think, is in Guyana and in Trinidad. And a knife got into a bag of cornflakes. And a customer bought it because it fell into the packet and it got into it, right? Anyway, so I just telling you, like, they have other words you can think. What if something else ends up on your product? Like a word for that is other than. There are more codes there, more or less. You could use another code, but you could set your own code. You don't have to use the ones, you know, I mean, Google have a bunch of them, but you could make your own code, right? And when you say other than, you think about what if something gets into this bag? What if a lighter falls in it, cigarette lighter, right? So what if a knife? Of course, that's a real one. I tell you, that sounds crazy, yeah? But that actually happened, right? A customer in Price Mart, I say it again, bought a bag of cornflakes and it had a knife inside of it. In the conveyor, a knife fell and got into the conveyor. It's an automatic system, and a knife was packed into the bag of cornflakes. Now you may think that's not harmful, but the issue is children and who open up bag of cornflakes anyway, right? All right, folks. Don't call me and ask me nothing about that. Eh? Those of us who may know what I'm talking about. All right, folks. I think we got to number 5 last week. Was this the same? Okay, the year may be different. But I think it's the same question paper, right? It just the paper repeated 2018, 2023. It's the same paper. The paper repeated. All right. Number 6. So this was the question I was talking about. Which of the following, actually no, this is not it, but this one like it. Which of the following is a leading indicator? The A missing there, right? I'll put this in one time. Probably delete when I was interfering with this thing. Which of the following is a leading indicator? Audit results, manufacturing defects, design failure, defective equipment. What is leading? Leading means anything that is what? Leading mean anything that is?
Good.
Good. So
Good.
which one there is good?
Audit.
Right. So audit results, there would be the one that is good. Right. We're going on. Number 7. I just taken a couple minutes of your time. Remember, I want to sort of incorporate it, right? Number 7. Which form of risk assessment is most appropriate when the risk is potentially intolerable? Think, which form of risk assessment is most appropriate when the risk is potentially intolerable? What did we say? We're looking for one that is what? More what? If the risk is intolerable, that means the risk is high. So we're looking for an answer that is more what? More objective or more subjective? Which one we looking for?
Objective,
So
and
which
that would
one,
be
yeah,
quantitative.
which of these techniques is more objective?
Quantitative.
Quantitative, D. The answer is D, right? You see how we do it then? Remember, I tell you when I do those calculations, I tell you them things are coming, but remember it's multiple choice. Now, again, there are some of us here, I mean, not everybody is everybody, right? Looking back at your class group, there are some people here that have move on to do the degree. There's a NEBOSH diploma. I don't think anybody here is on the diploma. Normally, I have sometimes I have fluctuating students and somebody may be in the diploma, but they come back to do process safety. I think Sharon is like that, but she's not on this live today, right? I mean, there is calculations I was saying, but you really don't get it in the multiple choice exam. Thank God for that, right? But the other thing is that at least some people like the Hazops and they like the ETA calculations, right? Some students like it, right? Okay, this one, you wanna have a go at this one? A permit to work is usually required in preparation for an activity with no risk, any risk, low risk, high risk.
And yours?
High risk. Mhm.
Okay, so the answer is actually high risk. Now we haven't really done permit yet, but that was the question that came.
But like my management thing, like for men like cutting the law and things make them to open the door and thing.
Yeah. Well, that's the thing though. I mean, I have seen that too. So it's not as if I'm by hotel, you know, those who know me, I hotel long, right?
But, sir, that question can go on any risk because you have to get a permit if you're gonna do depends on the type of job you're
Yeah,
doing.
yeah.
They must evaluate what's the hazards and identify them and how we can mitigate them. So
Yeah.
I would say it can be a high risk. It's more than likely it's a high risk for any job as well.
Yeah. Yeah, so very good. It is going to be high risk. But what happens though? You find like in companies, some companies is use a permit for everything. Like, you know, housekeeping, they using a permit for that. And that's not
Oh
the
yeah,
purpose
the
of a permit.
company we work for, we do a
Yeah.
permit for everything.
Right, but that's not the purpose of a permit. What they should be using there is like a GSA, a job safety analysis, a GSA or a JHA. Permits are meant for work activities that are high risk, right? And but that's even not today's class, but high risk could be things like, well, high risk is if you use the formula calculation, but there are activities that are high risk, like confined space work is always going to need a permit, right? Working on excavation is always going to need a permit. Work on a high tension line is, you can't, that is never going to be low risk, right? So a permit to work is a document that should follow like a GSA or a job hazard analysis, right? And that's exactly what number 9 is kind of asking here. This is why I have said to you all, well, I had two minds about having to do a whole paper because, you know, we're still building the knowledge now. But at the same time, I do think you could still put an answer to these things and still send them in, you know, for me, you know, anyway, right? But you know, let me just do number 9 and number 10 and we'll stop, right? And we can still make a guess, right? Which of the following is most likely to help you develop a safe system of work?
Task analysis.
It is task analysis. In fact, a GSA, that's actually the heading on a GSA, task analysis. You know,
Right.
you know. Okay, last one and then we'll stop, right? Let's see if we can figure this one out. Inspecting a workplace, take your time, but the answer there, remember there's a thing about multiple choice. The answer there, right? The answer there, but the thing is, yeah, they get the best one, right? So inspecting a workplace where contract workers are carrying out work. Put yourself in it, right? Inspecting a workplace where contract workers are carrying out work is what type of monitoring? Is that performance monitoring? Is that actively monitoring? Is that condition monitoring? Is that reactive monitoring? This is a kind of tricky one, right? Inspecting a workplace where contract workers are carrying out work is performance monitoring, actively monitoring, condition monitoring, reactive monitoring. While you're thinking about it, I'm going to grab the register.
I believe it's performance monitoring.
Okay, the rest of you, what's already answering a bit.
I think it's actively monitoring.
Good answer. So you can try to excel the ones that doesn't make sense. That's one way of getting it. But like D is definitely wrong. I mean, speaking of D, right? D can't be the answer because, you know, reactive is if something have gone wrong now, right? And nothing didn't seem to go wrong as yet. So D is kind of out, right? So we probably down to A, B, or C. Anyone has anything you can knock off? That's the thing about multiple choice. Remember though, we mentioned the hour and a half you'll have on the assessment D. The thing though is that remember they do repeat. So if you get it again, well, great. You know, you just shade it and you go. You just shade it and you go, right? You know, a lot of people, by doing the repeats, a lot of people, by the way, past papers is the key to passing any process exam. Give half of the question coming back, right? And there's only 24 you need to pass, and it's half is like 20, right? So a lot of people do, you know, this course I say don't really have a failure rate with it. So I would want to agree and to send you all off because we have been, we have been here long anyway. The answer is going to be B, right? So inspection falls under active monitoring, right? That's just how it is, right? In the world of monitoring, active, we have things that fall under that. Inspecting is one, audits is one, surveys is another one, sampling is another one, taking a tour or a walk around your company is another one. It will fall any other place, right? So yeah, okay, so Anna, I'll put you present, right? Our boss is only 11 a.m., so I'll put you all present. Okay, folks, so stop the recording here.
Sorry,
could
sorry, I
you-
have to leave now because
Okay.
I'm going off to work. Sorry.
Yes, okay, not a problem. Okay, well, let me
Could you just explain what is condition monitoring? Is it just monitoring
I think
the
condition monitoring, that
environment?
is more for equipment. So I'll use
Mm.
again a household example because I know the process examples may be a little bit strange for some people. Like, okay, like if okay, so you start your car,
You ready?
right?
Mm-hmm.
And you
Huh?
look at the operating conditions then, right? So if you look at your fuel level, right? Those sort of things, that is condition monitoring. You could even think about maybe something like you heard a strange noise, right? Like something in the, I mean, God forbid those things in any cars anyway, but that is condition monitoring, right? In the plants, it may have been like a conveyor, a compressor, and like they would look at the compressor while it's running then, right? So they can look at the RPMs, the revolutions. If there's a belt between the pulleys, they can look at the condition of the belt. Same thing with your cars. Does the belt need to change, right? So you look at that. If it seems to be good, it seems to be dry rot, it seems to have a thread hanging out of it, that's condition monitoring, right?
Noted. Thanks.
Okay, all right, let's get it rolling. Did I stop the recording? I can't remember.
No.
Well, here the thing, right? Those things we are reaching yet now. That is